one thing. Now, can you please tell me the name of this? Yeah, write down the IUPAC name of this. Let's see you got the point or not. Right. Write down the IUPAC name. Yeah, done.
Ma'am, our message is to, can you please check the answer?
Yeah, sure. Two bromo, two methyl pent 3E. Okay, you said it is two bromo. I'm writing your answer here. Two bromo, two methyl pent 3E. Right? And what about you, Jubita? Yeah, Jupiter has said it's 4 bromo, 4 methyl, pent 2E, pent 2E. Let's check whose answer is correct. Yeah, see. So what we have to do first, we have to see the parent chain. Longest chain is the parent chain, right? So this is your bromine, right? So longest chain is this, right? So we have to number we have to give the least number to this double bond first, right? So when you start the numbering from this right side, so this 1 2 3, right? This double bond will get three number, third position, and from here this double bond get 1 2 position, right? So obviously we will start from here, right? So 1 2 3 and 4, and this is 5, right? So on the fourth position, there is a substituent, right? So bromine and your methyl group. So it will be 4 bromo, 4 methyl, pent 2 ene. Got it? It's wrong, Muniba. 2 bromo, 2 methyl, pent 3 ene is wrong, right? So this is the correct one. 4 bromo, 4 methyl, pent 2 ene. Got it?
Yes,
And okay, if I give you, just tell me, uh, which bond, which one of the following halide, halides contain X, right, halogen group which is bonded to sp2 hybridized carbon, right? sp2 hybridized carbon, this bond. Which halide has this bond? Means your halogen group is bonded to sp2 hybridized carbon. Option is allyl halide, allyl halide, right? Option B is benzyl halide. Option C is alkyl halide. And your option D is vinyl halide. Vinyl halide. Yeah, tell me which option is correct.
option D.
Yeah, it's D, right? It's vinyl halide is the correct one. Because you can see over here, these three are allyl halide, benzyl halide, and alkyl halide. All are the types of halogen which is attached to sp3 hybridized carbon, right? And this vinyl halide, it is the halogen group is attached to sp2 hybridized carbon. So that's the correct option. Okay, got it? So let's start the today's topic. Yeah. So nature of CX bond. Nature of CX bond. Now what is C? तो कार्बन एंड हैलोजन के बीच में जो बॉन्ड होगा तो what is the nature of that bond? So let's discuss, right? So we know that, right, when this bond will break, right? So will break. So this is your highly electronegative atom, right? This halogen is has greater electronegativity, right? So halogens are your fluorine, bromine, and iodine. We know that. Okay, so due to higher, high electronegativity, when this bond will break, this X will have partial negative charge, right? This X halogen will acquire partial negative charge. On the other hand, this carbon, right? This carbon is electropositive element, right? So when this bond will break, this will have partial positive charge. Always remember this, right? Why this happens? So due to high electronegativity of halogen atom, right? So halogen group in carbon and X bond, so it will acquire the partial negative charge, and on the other hand, this carbon will acquire partial positive charge. Got it? So that's the nature of CX bond. Okay, right now. Done? Have you guys written? Okay. Okay, let's do one more thing. Let's understand how to draw the isomers of alkyl halides. Just a second. Yeah, so basically, isomers of haloalkenes, right? Now, tell me what do you mean by isomers? Do you know what is isomers? Have you heard this word earlier? Yes, anyone? Muniba or Jibita? What are isomers? Bacho? Yes, unmute yourself and please speak. Isomers. What are isomers?
Like molecules which have the same molecular formulas. The structure is different though.
Yeah, yeah. So basically, isomers are those uh, different compounds which have same formula but different arrangement of atoms. Right? In the same molecule, there you will see the different arrangement of atoms. So that's the isomers. Okay, means the formula will be same, but the arrangement of atom will be different. So that's the isomers. And isomers are haloalkanes are of two types. First one, chain isomers, and the second one is your position isomers. Position isomers. Right. Now, what is chain isomers? So, chain isomers differs in parent chain length. Right. So, these type of isomers differs in parent chain length. Chain length will be different. You will see the chain length of isomers different in parent chain length. Chain length. And position isomers differs in position of halogen group. Right. So, it differs and the position of halogen group is different. Halogen. Yeah. Okay, let's understand this by doing one question. So how to draw the isomers. Okay. So first understand these. So for to draw any structural isomers, right? So a structural isomers could be your chain isomers or position isomers. So always first determine the possible carbon skeleton. Okay, first try to draw the carbon skeleton for the given molecular formula. Okay, then then attach the halogen atom to various position, different position पे आपको attach करना है halogen group को. Okay, to ensure each unique arrangement, you have to draw each unique arrangement, not the same arrangement. Got it? What I said, again, I'm just repeating. To draw any structural isomers, to draw any isomers of alkyl halide, right? So first, try to determine the possible carbon skeleton for the given molecular formula. Suppose if I give you, it's a NCERT question. I'm just giving the formula C5H11Br. Okay. So first step of this will be first determine the possible carbon skeleton, right? So what will be the possible carbon skeleton? Just draw it. Okay. So I'm just drawing the simple 1, 2 carbon, 3 carbon, 4 carbon, 5 carbon, right? 5 carbon and there's a one bromine group. So bromine, right? So 5 carbon and you can see 11 hydrogens are there. Okay, 1, 2, 3, 3, 3, 6, 9, right? 10, 11, right? So there are 11 hydrogen groups. So this is your uh, basic structural or carbon skeleton, right? Possible carbon skeleton for the given molecular formula, right? So you have attached this bromine group here. Now just check it. Just attach this bromine group on different carbon position, right? So first try to name this compound what it could be. So it's one, right? So on the first position, bromine is attached, right? So it's one bromo. And what is this? How many carbons are there? Five carbons. One, two, three, four, five. So it's pentane. Pentane. Now, just shift. You have to shift this halogen group to each and every carbon, right? And you have to check whether it is giving the unique arrangement or not. Okay, so let's shift this. So this bromine group, right? So let's shift here, right? So it will give you one, two, three. Just a second. One, two, three, four, and five. Right. One, two, three, four, five. Five carbon is there. Now attach this bromine here. Attach this bromine here. Right. So when you attach this bromine here, so this is your unique structure. Yeah. Right. The attachment is different. So what is the name of this compound? One, two, three, four, and five. So its name is 2-bromo pentane. Right. Write down the next one. Now shift this bromine here, this carbon. Right. So it will give you this bromine. Now name this 1, 2, 3, 4, and 5. Right. So this is your 3-bromo and 10. Similarly, just try to. Okay. Now this is the same thing when you shift this bromine here, right? You can see here when you shift this bromine on the fourth carbon position, so it will give the same arrangement. It will give the same arrangement just like this 2-bromopentane. Okay, same arrangement he dega. So it's not the unique arrangement. So that's it for bromo. When you shift the bromo now, just try to attach or try to make the branch, right? When you shift like first one CH3 group and when you attached one CH3 group on any branch structure, for example, अगर मैं just like this is your butane structure, right? So there are 5 carbon, right? So just remove one carbon from this. So just make it butane. 1, 2, 3, 4. Just a second, it's 5. Just 5. So it's 1, 2, 3, 4. Right. 4 carbon is there, right? And for one more carbon, just do the branching here. This is now you can see there are 5 carbons here. 1, 2, 3, 4. And this one is your 5. आपने यहाँ पे branching दे दी CH3 के, right? So this is again a carbon structure, right? So 1, 2, 3, 4, and this is your 5. Now just add this bromine group here, right? So this is your another isomeric form. ये समझ आया? Clear or not, Jyobita and Muniba?
Yes, ma'am.
Yeah. First, always try to just shift the halogen group. Okay. After you got all the isomeric form, when you shift the halogen group, just try to make another arrangement by altering into the methyl group, right? The carbon position. So it's a 5 carbon, right? So just try to make the branching from this, right? तो आप 4 carbon position 4 carbon की एक straight chain ले सकते हो, and for 1 carbon you can add one branching over here, one substituent over here, right? So you will get the another isomeric form. So what will be the name of this? So it's, you can start from here. So it's 1, 2, 3, and 4, right? So what is the name of this? And you can check it. This is the C5H11Br. Again, this is the molecular formula is same. Okay, I'm not going to alter this formula. The formula is same, but I am just arranging it differently, right? The arrangement of atom is different, but the molecular formula is same. Okay, so that's why it is known as isomer. So just try to name this. So it's on the second position, it's methyl group, and on the first position, so it's bromine group. Okay, so alphabetically order mein when you write down, so first bromine comes. So for one bromo, three methyl, right? It's one, two. It's two methyl, sorry. It's two methyl, just correct it. One bromo, two methyl, and there are 4 carbons. Got it? Do the second one. Next one. Yeah, similarly, you can, another you can do, just try to 1, 2, 3, 4. 4 carbon, 1 methyl group again. Now just try to attach the bromine is here on the first position. Now attach bromine here on the second position, right? So another isomer, you got it, right? You got another isomer. So what is the name of this? It's 1, 2, 3, and 4. So what is the name? So it's 2 bromo, 2 methyl butane, 2 methyl butane. Got it? Okay, so you have to shift this bromine, right? First, again, I'm just explaining it to you. First, try to make the carbon 5. Okay, so 5 carbon structure, 5 carbon straight chain. Okay, and try to change the position of the halogen, this bromine group. Okay, so accordingly, you got the 3 isomeric form. Now, what you are supposed to do, just remove 1 carbon from here and just draw the 4 chain isomeric, 4 straight chain carbon, right? 4 straight chain carbon structure, and for the 1 carbon CH3 methyl group, just add the branching over here, right? And now try to dash the halogen group. Okay, now you got the another isomers. Now you have to alter the position of this bromine group. Okay, in the same structure, right? So when the bromine is at the first position, this is the isomer. When the bromine is at the second position, this will be the isomer. Right now, try to just change the position of this bromine. When the bromine is, when you attach this bromine on the third position, okay, just try to attach 1, 2, 3, 4. Okay, this is the 4 carbon chain, butane, right? And here the methyl group was there, right? And you are shifting this bromine, right? So just try to shift this bromine. So you got this, right? So this is the structure. And what is the name of this? So 1, 2, 3, 4. Right. So try to name the halogen. Halogen ko lowest name do. Lowest number do, right? So when you start the numbering from here, 1, 2, 3, 4, so halogen will get third number. But when you start the numbering from here on the left side, so it will get second number. So, right. So the correct numbering is this 1, 2, 3, 4 from the left side. So that's how you got the name. So it's 2 bromo, and on the third position is methyl. So 3 methyl, and what is this? So 4 carbon chain, so it's butane. Okay, now let's check. Is there another isomeric form also exist? Let's check once. Yeah. Yes, Muniba. Yes. Do you have any problem, doubt?
No, ma'am.
Okay. So see, one more. Yeah. If you shift this bromine here, if you shift this bromine here, you will got another one. So let's shift this 1, 2, 3, 4 carbon chain, butane. Right here, the methyl group is there. Now we are shifting this bromine group, which was at the second position. So हम first पे shift कर रहे हैं. Right. So here the bromine is attached. Right. So you can see this is this and this is your another structure. These two are not same. It's one bromo, two methyl butane, but this is your 1, 2, 3, 4, and just a second. Yeah, yeah, it's correct. And you get the 1, 2, 3, 4. Just a second. यहाँ से start नहीं करेंगे numbering. So that's a carbon. Yeah, so that's a carbon. 1, 2, 3, and 4. Okay. So we will start the numbering from this carbon. So what's the name of this? So it's 1 bromo. Right, on the third position, there is a methyl group. So 3 methyl and it's butane. Right. Another thing we can do is we can, yeah, we can also add, yeah, on the, you can see on the second position, there is a bromine group and the methyl group is there. Right. So you can also use this. Like, you can also use a propane, right? When you short the ring, आप जब short कर रहे हो chain को, right? आप chain को short कर रहे हो because first we have draw it for pentane, then after that butane, then we can check it for propane also. So 1, 2, and 3 carbon chain. 1, 2, 1, 2, and 3 carbon chain. Okay, attach and two because the formula is C5H11Br, right? So 3 carbon we have drawn. Now two are left. So two for two we can add the branching, right? So this is one methyl group, and again this is second methyl group, and one bromine is attached here, right? So this is another isomer, right? So now try to name this. So from here, this carbon 1, and this is 2, and this is 3. Right. So what is the name of this? Yeah, who will tell me? Tell me the name of this isomer. Yes, Muniba. Try to name this isomer. You can write it as CH3, CH3 here, CH3 here, and CH2 and Br. Right. Now try to name this. This is a long chain, right? 1, 2, and 3. Right. So what will be the name of this? 1 bromo. Yes. 2.
2,2-dimethyl.
Yeah. 2, 2 dimethyl propane. Good. Okay, now you can check if another isomeric form also exists or not. So that's a possible isomeric form of C5H11Br. Okay, so 8 isomeric structural isomers exist for this. Okay, so that's how we just draw the structural isomers of any given molecular formula. Okay, I will give you one homework on this. Right, I will give you, just try to make all the possible isomers based on this. Got it? Any doubt in this?
No, ma'am.
Okay, please draw it. written?
One.
Okay, just draw it and please update me. Now done?
Yes.
Okay. Okay, so next topic is method of preparation of haloalkenes. Okay, so that's very important. So just please be focused here. Method of preparation of haloalkenes. So let's see what are the methods by which we can prepare the haloalkenes. First preparative method is from alcohols, right? So this is the most common method for the preparation of haloalkane, right? So in this process, basically, the replacement of OH group, okay, OH group from an alcohol by the required halogen atom, you will see. What happens? The OH group will be replaced by the halogen group. Okay, so let's see one by one. So first preparative method is using phosphorus based reagent, right? Phosphorus based reagent से हम बना सकते हैं haloalkanes. So when this ROH group, right? When your ROH group, right? R is any alkyl group here, and OH, you know very well, it's alcohol, right? So any alcohol, when you react with PCl3, right? So PCl3 is basically phosphorus-based reagent, right? So in this way, you will got RCl, right? R is your any the taken alkyl group. If it is CH3OH, so you will get CH3Cl when you use the reagent PCl3, right? So basically, you just have to remember the reagent, right? So in what reagent we will use to for the product this, okay? Like PBr3. When you use PBr3, you will get RBr. Okay, required haloalkene over here. Okay, third one, third one is your phosphorus plus X2. X2 could be your bromine, Br2 or I2. You can use with red phosphorus. आप क्या use कर सकते हो? Br2 or either I2. So you will get Rx over here. And what is Rx? So X could be your bromine or iodine. Now see, when you use PCl5, okay, so when you use PCl5, you will get again your haloalkane. Now see, there are some similarities when alcohol, when it is treated with PCl3, PCl5, and one more acid, which is your thionyl chloride. Thionyl chloride is SOCl2, right? So in तीनों के साथ जब आप react करते हो, तो again you will get your RCl, right? you will get your RCl, chloro, chloroalkane, right? Chloroalkane. So you will get. So, but the main thing, the difference is in the byproduct. You will get the different byproduct in all these. But the main product will be same. You will get RCl. When you treat alcohol with PCl3 or either PCl5 or either SOCl2, the main product will be same. That is your RCl. Okay, but your byproduct is different in all the case. Right. In the case of PCl3, you will get H3PO3 as a byproduct. And in the case of PCl5, you just got HCl plus POCl3. Okay, so just remember that. That's the difference between these. Got it? Yes or no? Is there need to explain it again? Yes, Moniba and Jubita. Tell me, बच्चों.
Yeah. Sure.
Yeah, so just remember from alcohols you can prepare the haloalkenes, right? And haloalkenes, so what you're supposed to do, just replace. You just have to replace this OH group by your halide, by your halogen group, right? So when you are using PCl3, just remove this OH group and just attach Cl group over here. You will get your RCl, right? And the byproduct in the case of PCl3 is H3PO3. Again, in when you treat ROH alcohol with PBr3, right? So in this case, again, just replace this OH group will be replaced by this bromine group and you will get RBr corresponding haloalkane. Okay. Now, third one, when you use red phosphorus and X2, right? So this X, this reacts with this will replace this one halogen group. It will replace this OH group and you will get RX over here. राइट अगेन PCl5 के साथ जब आप रिएक्ट करोगे अल्कोहल को अगेन यू विल दिस OH will be replaced by your corresponding halogen group right so here you are using Cl right PCl5 so Cl you are using so you will get RCl right but the byproduct will be different are HCl and POCl got it
Yes, ma'am.
okay if you got it just let's do these questions first one first one just tell me the product when this CH3, this is CH3, CH2OH. When it reacts with PCl3, what will be the product? We know that this OH group, it is replaced by this halogen group. So you will get CH3, right? So this is CH3, CH2, and here you will get Cl, right? ये OH replace होके यहाँ पे chlorine attach हो जाएगा. That is your main product. So no need to write down the byproduct. So you just have to write down the main product. Okay. Next one. Tell me the next one. What will be the answer?
In place of OH, it will be
Yeah, very good. So here the bromine will be attached. This one.
in case of OH, and
Yeah. Okay. So just remember this. That's very easy. You just have to remove the OH group, right? So OH group is replaced by the corresponding halide, right? Halogen group. So here you are using I2. So on the in the place of OH, you just attach the iodine group, right? So that's the product. Got it? Jovita and Muniba? Yeah. So write down first. Write down this method of preparation of haloalkanes and first write down the from alcohol. From alcohol में part 1 डाल के लिखना using phosphorus based reagent. Chetan, can I scroll down?
Yes, ma'am.
Okay. Yeah. Second method is using thionyl chloride, right? So by using thionyl chloride is nothing, it's a SOCl2. SOCl2 को हम क्या कहते हैं? Thionyl chloride, right? And the structure, you can see the structure of thionyl chloride is this SO and this Cl, right? ये होता है structure thionyl chloride, right? So when alcohols they are treated with thionyl chloride, they form corresponding alkyl chloride, right? Plus the byproduct is your HCl and SO2, right? Both are in gaseous state, right? HCl and SO2 they just evolve, they just liberate from the chemical reaction, and you will get a pure compound in this case, right? So see the reaction when the ROH alcohol it reacts with SOCl2, and basically this reaction proceeds with a pyridine, right? इसमें हम क्या use करते हैं? Pyridine, it is a base, right? So pyridine, the structure of pyridine is this, right? So in this reaction we use pyridine along with thionyl chloride. Okay, so when this ROH it treats with when it is treated with SOCl2, you will get corresponding alkyl chloride RCl. Okay, plus what are the byproducts? So your byproduct is HCl plus SO2, right? So basically this SO2 and HCl they are in gaseous phase, so they just evolve out, evolve out from the reaction, and in this case you will got the pure product. Okay, so that's the major, you can say that's a major merit, right? That's a major merit of this reaction, right? This is the best method to prepare the pure alkyl fluoride. Why this is known as the best method? Why it is called a best method of preparation from the alcohol? Because in this you just get the pure alkyl fluoride. आपको यहाँ पे प्योर अल्काइल क्लोराइड मिलता है. Why? Because these byproducts, right? These byproducts are in gaseous state. तो gaseous state में होने की वजह से what happens? They just evolve out from the reaction, right? They just evolve out and you just get the pure alkyl chloride here. But in above cases, you can see these are the byproducts are in solid form, right? Either they are in solid or liquid phase, right? So वो तुम्हें pure compound नहीं मिलता as a product. Okay, so you don't got the pure compound as a product. So in this case, the what is the major why it is known as best method of preparation of alkyl chloride from alcohol? So due to the in this process, in this method, we just get the pure RCl, alkyl chloride, right? Because the byproducts are in gaseous state, so they easily just escape out from the reaction, and you just get the pure form of compound. Got it? Yeah, yes or
Yes,
not?
ma'am.
Suppose, for example, this is your example CH3, CH2, CH2, and OH, right? So this is basically your propanol, right? The propanol, when it treats with when it is treated with SOCl2, and obviously it is known that here is a pyridine also, right? So you just got this OH group is replaced by again your Cl group, right? And you will get a corresponding alkyl chloride, right? You will got a chloropropane over here plus HCl and SO2. They just evolve out from the reaction, and you will get the pure form, right? This is the pure form of your alkyl chloride. Got it? So simply what you have supposed to do, अगर आपको reagents दे रखा होगा, right? यहाँ पे अगर आपको reagent दे रखा होगा and um, for example, any alcohol it is given, and just give you the reagent associated, right? So just it's very easy. Just remove this OH group and just add chlorine group here. And what are the byproducts? The byproduct is your HCl and SO2, right? SO2 and HCl, they are in gaseous phase. So just you can just write it down just like this. Yeah, so again, here's a question. I just explained it to you why thionyl fluoride is preferred method of preparation of alkyl chloride from alcohol. So why we just prefer this method? So because the byproducts HCl and SO2 are escapable gases, right? So we just get pure alkyl halide in this case, hence there is no need of purification, right? So further हमें कोई भी need नहीं होता purification का. We just get the pure form of alkyl halide. That's why this method is more preferable method of preparation of alkyl halide from alcohol. Got it?
Yes.
Okay, write on this. Then we will see another method of preparation from alcohol, and after that we will discuss some questions. Dan, can I scroll down?
Done, ma'am.
Okay. I don't know why my laptop is not working today. Yeah. After that, there's a again this one. Just mark it as a C. Right. This is a method C part. Right. Again, it is a method of preparation from alcohol. Right. But here we just use the halo acids. Right. Halogen acids. Halogen के हम acid use करते हैं. Right. So now see, let's see. So basically, the treatment of alcohols with HCl in the presence of anhydrous ZnCl2. What we use as a reagent. So we use anhydrous ZnCl2 plus your HCl, right? So to give the alkyl chloride. Okay, so basically, alcohol when it treats with HCl and anhydrous ZnCl2, so it will give you a corresponding alkyl chloride. Okay, and what are these reagents known as? So these combination HCl और anhydrous ZnCl2 का combination जो है, this is known as your Lucas reagent, right? This is known as your Lucas reagent. Just remember that. Anhydrous ZnCl2 plus your HCl, these are known as Lucas reagent, right? So see here. So when ROH alcohol, it treats when it is treated with HCl in the presence of anhydrous ZnCl2. So what happened? It just give you RCl plus water. Okay. Let's understand this mechanism first. So I'm writing the mechanism over here, right? So suppose it's ROH. So we know that it has a lone pair. Oxygen पे क्या है? Lone pair है, right? Now, when you give HCl, right? So HCl means H plus and Cl minus, right? So this chlorine is more electronegative, so it will get negative charge, and this H will get positive charge, right? So this H, it will attack on this, right? It will attack on this oxygen, and it will give you ROH2, right? ROH2, and here the plus charge. Right. So this OH2 this is quite unstable. So from here, the water will liberate out. यहाँ पे क्या होगा? Water निकल जाएगा. Just remove the water from here, right? Minus H2O, right? So, and this is R plus, right? So here, the chlorine. So H plus just attack in the first step, and this chlorine minus, it will attack on this R group, and it will give you RCl. RCl plus your water. यहाँ पे क्या हो रहा है सेकेंड स्टेप में सो इट्स डिहाइड्रेशन हो रहा है तो वाटर इज रिमूविंग फ्रॉम हियर राइट सो इट्स OH2 मींस 2H H2O राइट सो H2O फ्रॉम हियर इट विल रिमूव आउट एंड यहाँ पे अल्काइल ग्रुप के पास क्या है दिस इज पॉजिटिव चार्ज ओवर हियर so this Cl will attack here that carbon right of alkyl group and you will get RCl plus your water. So that's the mechanism in this reaction. Clear, Huniba?
Ma'am, where is the ZnCl2?
ZS will just act as a catalyst. Yeah, ये directly involved नहीं होता, it just act as a catalyst. Here the main reagent is your HCl, right?
Alright.
So just remember, you just have to remove this OH group and just attach this chlorine group over here, right? And water will be liberated out, right? So that's the whole mechanism in this reaction. And yeah, this HCl and anhydrous ZnCl2, we know that it is a Lucas reagent, right? So this Lucas reagent is basically used for the distinction test, right? So it is used for the distinction between primary, secondary and tertiary alcohol, right? तो जब हमें distinguish करना होता है primary whether the unknown compound is primary alcohol, secondary or tertiary, so we just do this test, this Lucas test. And in this Lucas test, we use the Lucas reagent. That's why this test is known as Lucas test. Okay, let's see what are these tests. So if our alcohol is primary one, okay, so when you treat the primary alcohol with Lucas reagent, then there will be no reaction at room temperature. Room temperature पे कोई भी reaction नहीं होगा, right? But But when you heat that, when you suddenly आप उसे heat दोगे, temperature increase करोगे, then you will see a white ppt is coming out. White ppt means that you your product is formed, means RCl formation हो गया यहाँ पे RCl का, right? Means your alkyl chloride is being formed. Got it? So in the primary, if the alcohol is primary, then it will give no test, no reaction at room temperature, right? So when you treat this Lucas, treat the primary alcohol with Lucas reagent, so it will have no effect, right? It will have no effect of the Lucas reagent on primary alcohol at room temperature, right? Just just remember this. It is at room temperature, but if you increase the temperature, you will this primary alcohol also give the test, give the Lucas test, right? But at room temperature, it doesn't give the test. Okay, so you have to, for the distinction between primary, secondary, and tertiary, you just have to test it on the room temperature, at the room temperature, right? So आप लोग first, अगर suppose आपका कोई भी alcohol है, you don't know whether it is primary, secondary, or tertiary, so just take that alcohol and just add the Lucas reagent, means your HCl and anhydrous ZnCl. So at the room temperature, so there will be no reaction, right? You will not get the white ppt over here. But when you give heat, when you give increase the temperature, so you will find that there is a white ppt coming out, and that white ppt is nothing. It's your product, right? It's your product, means that is your alkyl chloride. Got it, Muniba?
Yes, ma'am.
Yeah, you will perform this in your lab, right? In your lab, you will perform this. And the secondary alcohol, if there is a secondary alcohol, the secondary alcohol on Lucas test, okay, on treating it with Lucas reagent, it will just give white PPT after 5 to 10 minutes. You have to wait for 5 to 10 minutes at room temperature, so it will give a test. बट दिस प्राइमरी वन, अगर आप 5-10 मिनट, हाफ एन आवर भी वेट करते हो एट अ रूम टेम्परेचर, तो इट विल नॉट गिव अ टेस्ट, राइट? तो आपको टेम्परेचर देना पड़ेगा, इंक्रीज करना पड़ेगा टेम्परेचर फॉर द प्राइमरी अल्कोहल. बट द सेकेंडरी अल्कोहल, इट विल गिव द टेस्ट, it will give the positive Lucas test after 5 to 10 minutes. After 5 to 10 minutes, you will see that white pipette is coming up. And white pipette is your RCl, alkyl chloride. But for the tertiary one, tertiary alcohol, it gives the Lucas reagent very fast. Okay, सबसे ज्यादा आपको Lucas reagent, Lucas test positive किसमें दिखता है? Tertiary, then secondary, then primary. Okay, so just remember the sequence: tertiary alcohol, then your primary alcohol, then your secondary alcohol, then your primary. Okay, just remember the sequence. So when your alcohol is tertiary one, so on addition of Lucas reagent, it gives a white pipette instantly, right? आपने, for example, आपका alcohol 3 degree alcohol है. And when you put the ZnCl2 anhydrous ZnCl2 and HCl in this, तो instantly आपको white ppt मिलेगा, डालते के साथ reagent आपने डाला और आपको मिल गया, right? White ppt. So that's a, so just आपको समझ में आ जाना चाहिए उस टाइम कि yeah, this alcohol is a third tertiary one, right? तो हमारा जो alcohol है, unknown alcohol, that is a tertiary alcohol. When it gives the white ppt and when it gives a Lucas test very instantaneously, right? So that's a tertiary alcohol. Okay, so that's Lucas test is basically used for distinction between primary, secondary, and tertiary alcohol. Got it?
Yes, ma'am.
Yeah, and the rate of reaction for haloacids, right? It's higher. The rate is fast in HI, when you are taking HI, then HBr, then HCl. So that's the rate of reaction when you take the haloacids. When these haloacids are treated with alcohol, right? So that the rate of reaction will be fast in HI. जब आप HI लोगे, right? Iodide लोगे, and the least you will, the rate of reaction will be very slow when you take the HCl. Right, so this is the sequence of the rate of reaction for the haloacids. Now you can write it down from here. Using haloacids, write it down. Done, Munira?
1 minute, ma'am.
Okay, okay, just write down.
Ma'am, can you repeat why the tertiary alcohols are more reactive?
Yeah, tertiary alcohols doesn't react.
That they're more reactive.
Basically, when you add, okay, I will explain it giving example. Okay, for example, if I take, okay, my primaries to start with you. So let's take CH3, CH2, OH, right? When you treat this with HCl, right, ZnCl. This is your primary, right? Secondary, let's take example CH3 dash CH3 over here. So this is a secondary alcohol, right? So when you treat this, let's see what will be the product. And when you see the example, this is your tertiary. Yeah, again here CH3 group. Now, see, for example, this, right? This. So because tertiary alcohols, we know that it reacts more readily with Lucas reagent, right? When you add ZnCl2 plus HCl, so it will react more instantly, right? So why? Due to, suppose यहाँ से OH group है, right? So when this OH group is removed, तो यहाँ पे क्या है, कार्बोकैटायन का फॉर्मेशन होगा, right? So here the carbocation is formed, and this carbocation is this due to the greater stability of carbocation, because this carbocation is very stable, right? So due to the greater stability of carbocation intermediate which is formed during the reaction, this will proceed by SN1 type of reaction, right? SN1 type of reaction होगा, और we know that in SN1 type of reaction 3 degree सबसे ज्यादा reactive होता है, after then second degree, then 1 degree. Okay, in the further chapter, इसी chapter में when I discuss the chemical reaction, so here I will discuss the what are SN1 type of reaction, SN2 type of reaction, right? So basically वहां पर कार्बोकैटायन का formation होता है, and carbocation, the 3D carbocation, tertiary carbocation is more stable, right? So due to the greater stability of this 3 degree carbocation, ये बहुत ही fast, right? यहाँ पे बहुत ही fast, ये carbocation की वजह से बहुत ही fast यहाँ पे ये Cl, it will just attack due to this 3 degree carbocation, because it is very reactive and very stable, right? ये बहुत ही reactive होता है 3D carbocation, इसलिए ये काफी बहुत ही fast reaction होता है. That's why this reaction proceed very fastly, and here the chlorine will be attached, right? So basically just remember that this 3 degree, right? Because when you just remove this OH group, right? So again here will be carbocation will be formed this, but this is secondary carbocation. But 3 degree carbocation is more reactive and more stable. Due to the more reactive nature and more stability, यहाँ पे बहुत ही fast reaction होगा. This chlorine, this is electronegative, right? So this will attack very fast on this carbocation. राइट, तो बहुत ही फास्ट यहाँ पे रेट ऑफ रिएक्शन इंक्रीज हो जाती है, राइट? बेसिकली ये SN1 टाइप ऑफ रिएक्शन, यहाँ पे SN1 टाइप ऑफ रिएक्शन होता है, एंड इन द SN1 टाइप ऑफ रिएक्शन 3 degree carbocation is more stable than 2 degree than 1 degree. That's why this reaction, the rate of this reaction is very fast. ये बहुत ही instantaneously हो जाती है, right? Than this, right? Primary carbocation है बहुत ही, you can say at the room temperature ये होता ही नहीं है, but in certain condition, when you increase the temperature, this will happen, right? यहाँ पे rate of reaction increase होते हैं, because we know that temperature increases the rate of reaction. तो हम जब increase करते हैं temperature, तो यहाँ पे rate of reaction increase हो जाती है. Why? Because यहाँ पे collisions increase हो जाते हैं, effective collisions. तो आपने ये chemical kinetics से पढ़ा होगा, right? तो chemical kinetics में you have discussed, no, I have not discussed over here because मैंने वो chapter अभी पढ़ाया नहीं है, right? तो स्कूल में आपका हो गया chemical kinetics, मुनीबा?
Yes, ma'am.
या तो वहां पे आपने देखा होगा कि basically temperature increases the rate of reaction. So that's why यहाँ पे when you increase the temperature, when you provide the external temperature, what happens, the effective collision increases between these molecules, and that's why the rate of reaction यहाँ पे थोड़ा fast होता है, और तभी ये this will give your RCl, right? This will give you RCl, but at the normal temperature, at the room temperature, ये नहीं होता. Got it?
Yes, ma'am.
Okay, so just remember this. Why in the this tertiary alcohol, why the rate of reaction is so fast? So due to this reason, right? So the mechanism of this reaction is basically SN1 type, and in SN1 type we just know that the reaction proceeds via carbocation formation, and the 3D carbocation is more reactive and more stable than the secondary or your primary. That's why in this tertiary alcohol, the rate of reaction is fast, is very fast. ये instantaneously हो जाता है. Got it?
Yes, ma'am.
Okay, if it is clear, let's do some question. आपने लिख लिया था पूरा complete notes?
Yes, ma'am.
Okay. Okay, so one question I want to just discuss it over here. Suppose it is benzene. It is benzene, and here OH group is there, and one, and here this OH group, right? This OH group is attached to sp3 hybridized carbon. Again, this is attached to this benzene ring. This is benzylic type of benzylic group, right? So when this compound, when you treat it with SOCl2, what will be the product? Tell me. यहाँ पे दो OH ग्रुप है, तो आप किससे रिमूव करोगे, राइट? सो जस्ट टेल मी. Okay, see, I will tell you. So there are two OH group, right? So you can see over here, this OH group is directly attached to this benzene ring, right? So this is involved in this resonance, this lone group, oxygen पे क्या है? Lone pairs है, right? So this is involved in the resonance. This is not free, right? This is not free for the protonation, right? Basically, this is not free for the protonation. तो आपका reaction कहाँ पे होगा? Obviously यहाँ पे होगा, right? So this oxygen will be removed from here, and you will get this OH will be as it is, right? And you will get Cl over here. This OH will be removed, and you will get Cl over here. Got it? तो यहाँ पे रिएक्शन नहीं होगा, ये दिस OH, ये काफी मुश्किल है इसे यहाँ पे से रिमूव करना, राइट? बिकॉज दिस OH group, this oxygen is involved in the resonance, right, with this benzene ring. Okay, so it is not free for the protonation. Okay, so that's why this OH will be replaced by this chlorine group, and you will get this. Got it, Muniba?
Yes, ma'am.
Okay, so that's all